Hello, everybody. Welcome to our webinar on the RDA ICT Technical Specifications. Thank you very much for joining. We are starting at the tip of the hour at 3 Central European Time. As a starting point, I'd like to share with you a little bit of logistical information that I think would be relevant. First of all, the webinar is being recorded and will make available the registration, the recording of the webinar shortly after over the upcoming days, together with the set of slides that are being presented. We have the opportunity also to engage directly with you, and we would like any questions you might have to post them in the questions section. All the questions will be addressed after the short presentations at the beginning of the webinar will be finalized. Once these presentations will be closed, our two panelists will address all your questions. So thank you for your patience on that. Our panelists, as I mentioned, are Rafael Reitz from the Max Planck Computing and Data Facility, and Florence Benezit from Trust IT Services, and who is also a member of the RDA Secretariat, who's following the RDA ICT Technical Specification procedures. Without any further ado, I'll pass on the word to Florence, who will introduce the ICT technical specification, the processes related to that, and how that fits into the standardization landscape. Thank you.
Thank you, Timea, for the presentation. I will start by giving some definitions, as you might not know already what an ICT technical specification is. A technical specification is a document with technical requirements that many things like products, processes, services, or systems can follow and comply with. A standard, which a word that everybody has heard of, a standard is a technical specification that has gone through a specific procedure and has been adopted and recognized by a standardization body. An ICT technical specification is just a specification in the field of information and communication technologies. So we are talking here of ICT technical specifications that have been identified. The identification procedure of ICT technical specification is what distinguishes an ICT technical specification from a standard. Practically speaking, an ICT technical specification, once identified, can be referenced in public procurement. Legally speaking, it has a status of common technical specification, and technically speaking, it complies with the Regulation 1025 Annex 2, which we will overview briefly later on. So why would the European Commission propose an alternative to standards? The fact is that the identification procedure is much more flexible and agile than the standardization procedure, and this allows the European Commission and Europe to keep up with the fast pace of technology development. RDA, which is the Research Data Alliance, has presented 9 of its RDA recommendations for identification. The identification procedure is shown on the slide. Let's focus first on the first and last box. It is interesting to note that only the Commission or a member state can submit an ICT technical specification for identification. And as you can see in the last box, the procedure ends with a Commission decision, and the publication of the ICT Technical Specification in the Commission Official Journal. So in the middle of this process, a key actor is the European Multi-Stakeholder Platform, which we call MSP. The MSP advises the European Commission on its strategy of ICT standardization. It is chaired and coordinated by the European Commission, and they meet on a regular basis. There are two kinds of members in the MSP. You have the standardization bodies that are represented there, but also, and it is an interesting thing in the MSP, is that you can find industry and private representatives also advising the European Commission on its standardization strategy. So now we're going to look a bit more about at the requirements to become an ICT technical specification, and there are 4 requirements. There's market acceptance, coherence principles, to make sure that there's no conflicts with existing standards, and there's also the compliance of the organization issuing the specifications. The organization has to be open, have consensus and transparency features. And finally, the technical specification itself has to have a maintenance plan, availability, IP rights, it has to be relevant, neutral, stable, and has a certain quality. So why would we have RDA ICT technical specifications? For multiple reasons, among which the promotion of innovation in data interoperability, and having it RDA recommendations referenced in public procurement will increase the implementation of RDA recommendations. How do RDA produce those recommendations and technical specifications? Anyone can join. It is open, in an open organization, and members of RDA work in working groups and write recommendations which follow a review process as explained on this slide. And anybody can join and write those specifications. So if you want to join, you can contribute to the to these specific technical specifications. So the first 4 RDA technical specifications have been published in July this year, and Raphael is going to go into more details on these 4 specifications. And under evaluation, we have 5 more RDA ICT technical specifications that will be evaluated at the end of the month. I will now pass the word to Raphael.
Yes, hello and good afternoon from my side as well. And while we are switching presenter here, and I think I still need to go to full screen mode, I thought. And I hope you will see the presentation now coming from my screen any moment. So thanks Timea and Florence so far for the introduction and generic and general part. I now join in order to present a bit more detail of what those first 4 accepted technical specifications are about. Not the least as I've been involved in generating them. So for instance, I was co-chairing the working group Data Foundation and Terminology, which we will address now next, but I also contributed to the other working groups and their results that we will cover in turn. That's why we thought it would be a good idea to distribute the presentation amongst us in this way. So first and foremost, what we addressed from the very onset within the Research Data Alliance is, to quote Bob Kahn, one of the inventors of the internet, you need to know what you are talking about. And as trivial as that may seem, it is not always clear in a technological or scientific environment that people actually speak the same language. Most importantly, referring to the same concepts and same ideas, or slightly more technically speaking, same model. And so what we set out to do at this group was to survey the current data handling practices in many communities and come up with a synthesis model that you will see any moment, thereby laying the foundation for what RDA wants to be dealing with, or a substantial part within RDA at least. And the first thing to note here in terms of scope is that we early on agreed that we only consider the domain of registered data, which does not imply that we would not be aware of the fact that there are also lots and lots of non-registered data. We simply don't address that part, and what registration means becomes clear as I go on. And we also appreciate that different disciplines are at different stages in terms of their evolution of data handling procedures, and this then also of course needs to be taken into account in some way. So appreciating the heterogeneity of the data that we are dealing with and the way they are organized with, how they are documented, the logical information behind them or so, we wanted to come up, as mentioned, with a common model, and from that we derived terminology, and that we then took also as a starting point to define policies and best practices, and that's what we are now going to address further. And the overarching goal was to define a common language clearly enough to mitigate the communication challenges that we are seeing in this domain. And the synthesis model, well, this is a graphical representation that we produced at the time. Here for this purpose only meant to illustrate what kind of objects and concepts we are dealing with. A digital object is kind of in the center of all this. Of course, we also appreciate that metadata have importance. Persistent identifiers have a premier importance. Digital objects can be aggregated. The concept of a collection, which is still further elaborated within the RDA context, comes into play. Entities, on the other hand, digital entities or bit streams are then constituents of digital objects. They can be put in a digital repository. So that's essentially illustrating the scope of the domain that we are dealing with, where we define concepts, introduce names, relationships, and all that goes with this. But even if you forget about all those details, one premier consequence of all of those considerations, as I've already mentioned in passing, is we apply this all to the domain of registered data, which in turn means if you want to adopt this and apply all the concepts that will follow, the first and foremost thing that you need to do is to register your data. And in practice, that usually boils down to get it a PID, a persistent identifier, at the very least. Then people often ask, why go through the hassle of assigning a PID in the first place if nowadays everything is on the web, all the things that we are dealing with have a URL of some sort. Why is that not sufficient? Well, we think it is appropriate and actually beneficial to become independent of network location, which after all is typically hiding behind a URL. But in addition to that, we also consider it beneficial to have a means to associate additional information with that identifier, which is not easily doable with the URL on the other hand. And additional information that should become accessible and available without even getting hold of the digital object in question itself. And that could be information about whether and where there are replica of that object, for instance, that may ease access, whether there are other versions around, if there are any, and if so, where, on which, where to find additional associated metadata, which maybe you are more interested in that than the object itself. Then things like a checksum that you can use for validation should you retrieve the digital object and want to check its sanity. And something like a data type that I will elaborate in more detail soon may also be appropriate. So for those reasons, we think it is a good idea to assign digital objects with a persistent identifier managed through some persistent identifier system that can then also allow the association of additional information. For instance, through a persistent identifier type registry or persistent identifier type records. So this was the core, or this is essentially the motivation for the, another specification for the persistent identifier types. The motivation I think I just gave. You want to be able to associate some key additional information or metadata with an object in a way that is independent of the object and its retrieval itself. And what the persistent identifier type working group was concerned with first and foremost was to specify a concrete model on how to actually express those data, and based on that to define an API, an application programming interface, through which people then in a standardized way are able to query, retrieve, and introspect those data. For the persistent identifier types, that is all I want to say here. Except maybe, as already mentioned in passing, that a very important piece of information in that context can and should be a data type information. So what the digital object in question, what is its type? And in order to handle data types in a more powerful way than we are able to do up to now or used to do, think of email or web where we have the MIME types, often corresponding to file formats. They already inform then applications how to deal with a certain digital object, whether it can be displayed using a specific application, for instance. Here it's in essence the same idea, but on steroids, so to say, in a more powerful way, more detailed, more granular, more specific as needed. And the main motivation, from a scientific point of view at least, is based in the understanding that it is usually very hard to understand a piece of data thrown at you somehow, or that you download from the internet, if it's not well documented or, technically speaking, typed. If you get a spreadsheet and there are columns and numbers in those columns, what do they mean? Oftentimes, even the generator of such a spreadsheet may not even be fully aware or exactly sure what it was, like in the example shown here. Was it a temperature? If so, which unit? Who knows? Maybe it was something different. I think you've all been in situations where you had those kinds of questions. And just imagine for a machine, there the same kind of problem is even harder if all what you have to begin with is a bit sequence. And And now what? Yeah, you need additional information in order to make sense out of that. And now a data type registry is a means by which data types can be generated, managed, accessed, disseminated. So something that holds data type records, but what is a data type then? And as already hinted at, a data type in our understanding is a characterization of data at any level of granularity. So whatever you feel is appropriate, could be to describe single individual observations or large structured data sets. The framework as such is supposed, and in the technical incarnations that we are seeing so far, flexible enough to cover the whole spectrum. And the requirement for a data type is that it must include information about the structural organization, the context, the assumptions that went into the data at question. So to refer to the previous example, specifying that, let's say, in a certain column of a spreadsheet, what's denoted there is a temperature, and the unit is Celsius. And you can easily imagine that if such information is made available explicitly, that can allow for further processing, unit conversion, fusion, scaling, and whatnot. Similar for the naming, also particularly important when you think of in contexts where interoperability becomes important. People usually denote same things, or oftentimes denote same things differently, but what did they use in order to denote what in which way? And then things like file formats or container formats, and how are they structured. And again, an important prerequisite for a data type to be conformant to this way of operating is that the linkage between the digital object in question holding the data that we are interested in and the type description need to be permanently linked. And of course, all we are talking about here is that they follow our agreed upon standards, that they are unique. This is actually a tough question from the management point of view. We don't want the same data type defined multiple types, but that's a tall order, in fact. And of course, they need to be discoverable. And in order to help us do this, the concept of data type registry has been developed, and we have prototype implementations thereof. Such a data type registry then holds collections of data types, provides them with unique and resolvable identifiers, again, PIDs. They may come with additional services and functionality, for instance, for validation. And the conceptualization that we have developed for data type registries is that there can be arbitrarily many, but they are supposed to be interoperable. And it is expected that a data type registry has both a user interface for human use and an application programming interface for machine use. And a typical example of usage may then be that a user becomes aware or interested in data of a priori unknown type, but through the linkage, through the type information, you can then ask the federated set of type registry, tell me what is this, what I have here, and you get back the type information, the data type register information, and with that information you can then invoke further services for visualization, further processing, and whatnot. So the concrete deliverables or outcomes that the RDA working group has produced so far culminate in what you see at typeregistry.org. This is led by CNRI, the lead developer of the currently available, or at least the one that I'm aware of, implementation of such a registry, known under the name CORDRA. This is a link to the working group that produced all this. In Europe, there is an organization called the European PID Consortium. They actually operate a DTR, a data type registry, and they also provide a test instance that you can turn to if you want to play around with that a little. And the fourth specification that we are looking at today also results from one of the first RDA working groups, this one being on practical policies and practical policies for data management, that is. They now in many ways build on this and use this and show how this can be put into action, so to say. But first, maybe, what do people here mean by the term policy in the context of data handling and data management? A policy is understood as being an assertion or assurance that is enforced about a collection of data sets or an individual data set. And areas in which that can be useful to have certain commonly understood policies or best practices are many, and from a very general point of view, many are listed here. So what data managers are typically dealing with one way or another, depending on where in the life cycle you are, people are dealing with things like replication, preservation, earlier on maybe with data management plans, later on with publication. You may want to check whether certain things are compliant with certain rules. Things may happen in federations. I guess our audience here is from the data management arena, so all this should somehow look and sound familiar to you. But what this group then also set out to do in order to come up with the results that you will see in a moment is they actually went through great pains and contacted many people to actually figure out what policies people use in practice. I mean, in their home at their home base, so to say, and they then grouped and categorized these, and so one of the outcomes of this group that may be of interest already without being part of any standardization or specification is just this collection of different policies for multiple tasks. And it was then also seen that for many policies it is possible to come up with a rough consensus. As it turned out that certain of these are used actually in multiple institutions. So that then also shows and goes that there is a certain generality, and based on that, best practices were then formulated, and this is what then entered the ICT specification process. And then, I consider this first and foremost kind of a guidebook and cookbook, what to consider and how to do certain things. And here again, you see the grouping, and there is this is all casted into a document where a grand total of 70 different operations from those areas are reported and explained. And here is just for illustration purposes that all those categories can of course be broken down further, and this is what's also explained in the outcome from this working group. And what you may be able to see from this is, in contrast to what I covered first, where we are really talking about concrete technological systems and procedures, persistent identifiers, registrations, data types, and the like. Here, the nature of the information that is being dealt with is covering a much wider scope and is more flexible and generic in a certain way. But it provides also then, based on that, policy templates, policies that could be adopted for verification. And last but not least, people also collected information on implementations with respect to automating many of these procedures. It just so happens that the IROTS community was very much engaged in this working group, and so many of the concrete implementations shown in the outcome of this working group are for IROTS, the Integrated Rule-Oriented Data System. Some examples are taken from labs or centers that use the General Parallel File System from IBM. But those implementations are meant as mere examples. If you happen to be using any such system, it may even be a good starting point for your own. But when you are really interested in getting further into this, the persons you would want to talk to are really Regan Moore and Rainer Stotzka. I think we also had a webinar earlier in this series on this very subject. So this is what I wanted to present to you in terms of what those specifications are about, really. And I want to close in reminding you of something that Florence already had included in the introductory part, namely that this is just the beginning of RDA results becoming ICT specification, technical specifications in Europe. At the moment, there are 5 further working group outcomes under review. There will be a session in Brussels on September 28th, if I recall correctly, where decisions may already be made in terms of accepting those, or at least we will get a step further. But with that, Florence and myself, we are at the end of what we wanted to present to you, and we are happy to take questions now.
Thank you very much for that, Raphael. Yes, so I'll mention again, there's a box in your command panel where you can insert any questions you might have, and we'll take it from there. They can of course regard also the introduction into the ICT specs which Florence gave, or further details that Raphael has addressed in his overview of the 4 currently acknowledged ICT specs. So we'll wait for further questions. If you will rather use the chat option, that is also available to you. So if you have any questions, we would warmly encourage them. In the meantime, okay, so we've already have a question from Herv. Could anyone point us in the direction of the process that ICT specifications go through? I think this regards the first part of the presentation, so I can pass on the question to Florence. If we understand correctly, you'd like to understand the process that she has detailed in her diagram. So from the submission of the ICT specs all through the official publication of the acknowledged specifications in the European Commission official records of the standards. If we misunderstood the question, please provide us with more detail. Okay. so Herb continues, and he provides more details that he belongs to another working group applying for an ICT status, and he'd like to know what they would be facing, or what how the evaluation session on the 28th will proceed. So I'll pass on to Florence, who will actually be on the 28th at the multi-stakeholder platform meeting, and will be presenting the ICT specs. Go ahead, Florence.
Yes, hello. So on the 28th of September, we are expecting the final advice of the MSP to the European Commission. They have already formed evaluation groups, and they have already studied the 5 ICT specifications, and they will have a last final discussion to reach consensus and give their final advice. After which the Commission will consult other experts if needed, and finally, if acceptance, publish the RDA ICT specification as identified ICT technical specifications.
If I may add to this answer, when I read, I like to know what we face on the 28th of September. I've been co-chair of, as I mentioned, of one of the working groups that produced an output that now has been acknowledged. As such, I personally didn't have to do anything. This was actually a great service from the RDA Secretariat, and first and foremost, Trust IT. Hilary Hanaho at the time took care of all the interaction with the Commission and the multi-stakeholder platform. Of course, every now and then she came back with questions to us where she was unsure whether she would be able to answer them correctly, or where further information was required in the process. But if your question results from you being involved in a working group that is not, whose outcome is now subject of the procedure here, you personally, or you as a group, do not necessarily have to do anything or much more than answering specific questions from, in that case now, Florence, I assume.
Yes, this is exactly it. It's the MSP working right now, and we provide extra information if asked.
Okay, Herb, do let us know if that answers your question. I'd like to pass on to, okay, thank you as well, Herb. I'd like to pass on to the next question. So Diba Marcus is asking if I understand, and I quote, if I understand correctly, the ICT tech specs will underpin the EOSC. How so if it's not standardized? So I'll give it a first try. Yes, we do say that the ICT technical specifications and all standards that that are promoted and used throughout in Europe will underpin in some way the European Open Science Cloud initiative. The ICT specs are standardized, so it's a lighter form of standardization that doesn't necessarily go through the sort of traditional way of the standardization efforts that we're sort of used to. So it's a quicker and lighter way to reach a close to similar results as with standards. But it's something that lasts, that takes less time, and thus it's considered as a way to encourage and incorporate innovation into the different organizations or projects or research work and business as well. I'm not sure if Raphael or Florence would like to add anything more to that?
No, I don't think I have anything specific to add. Maybe except to say that the European Open Science Cloud is, of course, in the end about more than what the RDA recommendations that have been acknowledged so far cover. But well, lots of things are still floating in the context of the European Open Science Cloud, but one thing that seems to become increasingly clear is that RDA has a lot to offer to the European Open Science Cloud, those ICT technical specifications being only one aspect. Also all the community efforts, the being a neutral platform, the tie-in into a global organization, so beyond Europe, that means for various aspects, RDA and the European Open Science Cloud will join forces, I expect, on many levels, and this just being one.
Okay, thank you for that. We'll pass on then to a next question coming from Riccardo Albertoni, if I read the name correctly. How are the technical specifications validated? Are they proved in pilot projects? I'll try to answer this as well. There's a validation and an endorsement process part of RDA, of the RDA processes. So basically, once a working group reaches the end of their of its lifetime, they need to deliver their outputs, so their deliverables, which are the different recommendations that are presented as the RDA flagship results, and these are usually supported by a set of adopters that the different working groups are responsible to interact with and provide at the end of their project's lifetime. So basically, all endorsed RDA recommendations, so the ones that are considered to at a certain point become ICT specs, are supported by through various cases of adoption and piloting. If you'd like more information on that, there's a specific section on our website which covers all the RDA recommendations and outputs, and we also have a section, a web page listing all the adoption cases, so the different organizations or projects or initiatives where the RDA recommendations have been implemented. When the ICT specs are submitted for evaluation, these need to be also supported again by clear examples of market uptake. So all the ICT specs that have been acknowledged have proven cases of use and adoption.
Yeah, I'm actually, quite frankly speaking, I'm not so sure that that was the subject of the question. At least I read that differently. Whether there are activities related to, in a way, assessing research data quality. And that's a tall order. And I would say at some levels, yes. In a generic way, no. I mean, if that question was rather in that direction that I'm just trying to get at, then I would consider efforts in the metadata domain to go in that direction. So, of course, you can check whether you have metadata in the first place, whether those metadata make sense in any defined way. Could be whether they are machine readable, whether they use a well-defined terminology or ontology and make reference to that. Such things can be can be evaluated from a more generic point of view. When data quality then also goes into the area of whether the experiment from which the data originate or the measurement have been done properly, how noisy they are. If you are considering those notions of quality, then I would say no, this is, or at least not from a very general point of view. On the other hand, there are discipline-specific efforts where people do try to assess those kinds of criteria. In weather and climate research, for instance, or environmental research more generally, people are addressing that. Also, I know in the agricultural world, people pay attention and think about ways how to do that. The agricultural domain, by the way, is quite strongly represented in the context of RDA. Climate research is also well involved, but there, when we are looking into discipline specificities, it's a mixed bag, I would say. Some disciplines are further ahead than others, and from a more general point of view, it's very hard to assess data quality beyond technical conformance to certain standards or statements like, yeah, this is using an open source or an open data format that's good or better than a proprietary data format, which also contribute, of course, to a certain notion of quality. But as I said, more generally speaking, rather than those very, very coarse indicators is tough and not systematically addressed within RDA, as far as I can tell.
Thanks for that, Rafael. Ricardo actually had two questions, but in between the two of us, hopefully we've answered. So let me just add to that, if you're very much interested in different aspects of research data quality, there are several groups that address these topics, as Rafael mentioned, and you can search our website. We have a complete list of all the RDA working and interest groups, and if anything pops up and it's in your line of interest, please feel free to join. It's open and free to everybody, so we're looking forward to contributions from all of you. Thank you again for that. Are there any other questions that that you'd like our panelists to answer? It's a very broad discussion, and we appreciate any feedback that you can provide. Okay, we'll wait for another couple of minutes to understand if there will be other questions, and in the meantime, we remind you that on our website, although there's so much information and sometimes it's very difficult to find it, we do have dedicated sections for all the RDA recommendations and the outputs, those that have been endorsed as such or are in course of endorsement, and each of them have a series of adoption cases that we try to highlight in order to showcase how the different recommendations can be implemented, and what have been the challenges, which have been the successful stories, and of course which are the lessons learned for that. Further to that point, in our plenary next week there will be another set of RDA recommendations published. 5 of those, actually, 2 in their final version and 2 in an initial state that is very close to being finalized, but to which you can of course contribute. We hope to have also a panel there present, and you can ask questions, so we look forward to that as well. Marcus has another question. Yes, if we'll upload the presentations with an email with slide and links. Yes, we'll upload all the presentations and of course also the recording of the webinar. Bear in mind that each of the groups that have generated the recommendations has a mailing list, so you can join that and join the discussions, and the chairs of the groups are always available to answer any questions you might have. So
I think if I may add to that, for most, if not all, of the 4 working group outcomes that we covered today, I think we already had individual webinar presentations. So by Peter Wittenburg, Larry Lennon, Tobias Weigel, and Regan Moore and or Rainer Stotzka. I'm pretty sure we've covered that in the meantime.
Yes, that's correct. So also, again, if you go on our website under training and webinars and past webinars, you'll find the list of past webinars that we've had on the different topics, and with the set of resources, recordings most of the time, as well as the slides. So and always feel free to contact the RDA Secretariat at inquiries-rd-alliance, where we'll do our best to answer any questions you might have. So thank you very much again. If there are no further questions, I'll thank you also to our panelists, and feel free to, again, to get in touch with us. We appreciate all feedback. Thank you.
Bye-bye.
Goodbye.